Good morning. It's a wonderful Saturday morning. I'm going to do a series of Chapter 11 videos real quick before I get tasked to go clean the garage. Alrighty, so let's get started. First one we're going to do is central angles, and I'm going to mention one little example on chords as well. Central angles is straightforward. It is straight definition given a central angle, and that is defined by the vertex being at the center of the circle. So as you can see, here's the center of our circle right here, and here we have an angle. It means that this enclosed arc right here, subtended is one of the technical terms, but I just like to say enclosed arc, is equal to that angle. So let's go ahead and take a look at this problem. We got WPX is equal to 38, so WPX is 38. So straight off the bat, we know that this arc is going to be 38 because it's a central angle. ZPY right here is 95. Now, very often we're going to ask you to find something, and you're just going to have to go out and find it, whatever we're asking for. And it's usually not straightforward, like 38, 38. Well, WX is pretty easy. Now, given that this is a diameter, this whole thing is 180. So we can find this angle right here by just simply doing 180 minus 95 minus 38. And this is just 47. Okay. And this whole thing also is a diameter, so we could do the exact same thing, 180. I'm going using my little pin here, and it sometimes moves a little slow, and sometimes it doesn't. 47. And this angle right here is 38. Now, why did I do that? I knew those were vertical angles. Duh, my brain's not turned on. Might as well find the last one. Boom, 142. I often do this. I sometimes don't even look at the problem. I just start filling everything in. So we know this 47, this 95, this 38, this is 142. And what are they asking for? ZY. ZY is 95. Well, voila. V, Y, W. So V is my starting point. This is where I start. This is my direction. So I go in that direction. So I got to go in Y. So I'm going this way. And I got to end all the way to W. So I'm going to add all these up and subtract from 360, or add them all up, or I could take this and subtract it from 360. However I wanted to do it. Well, actually, it's going to be easier to punch fewer buttons this way. 142, enter, 218. So this whole thing is 218. Okie dokie. So let's take a look at the next example. Now, in this example, we're dealing with chords, basically, and a radius. There's a radius in here. So let's go ahead and take a look at this. Here we have a radius all the way down here to the end of the circle. This length is 20, this is 5, so the radius is 25. Okay? And then we have a chord, and this chord comes right around here. Now, one of the properties of a radius and a chord is if the radius intersects a chord at 90 degrees. Now I can have a radius come from every direction, but when it intercepts at 90 degrees, it bisects this chord. This and this are going to be the same. That's one of the definitions. So this is bisected. Doesn't help it else just yet, but guess what's going to happen? We're going to have to use our right triangle properties to figure out the length of CE. Well, if we just find CD, well, the C, we'll call that EF, or whatever that point, it doesn't matter. This point right here, if we can find this segment, we're just going to have to double it. We can do that by finding right triangle properties. Looky here. I'm going to draw two right triangles, or one isosceles type triangle. And what I have here is a right triangle with a radius here, well, and that's not a radius, but a radius here. So we know the radius is 25, so this length is going to be 25. So here is my little triangle right here. This is 25, this is 20, and we'll call this A. And it's A squared plus B squared equals C squared. I know this is a triple because it's a 3, 4, 5 triple with a scale factor of 3. All right? 5, silly me. So this is 15, and I can show you on the calculator real quick how I did that. So it's going to be A squared plus B squared equals C squared, but it's 25 squared minus 20 squared gives me 225. Oops, I forgot to do that. 25 squared minus 20 squared gives me 225. Square root of that is 15. So I know that this is 15, so therefore this side is going to be 15, so the whole thing is going to be 30. Now, what is the angle of CBE, this right here? And let's go back up to here. We have 25, 20, and 15 as our sides of our triangle. And we're looking for this angle right here, but we're going to double it because this is an isosceles. This is bisected, so we know that these two angles are equal. All right? So these two angles are equal. If I could find this angle, I just double it. Well, when we don't know any of the angles other than the 90, we're going to use trig. One of the easiest trig ones is do the inverse of your opposite over hypotenuse, which is sine. So sine opposite, which is going to be 15, over 25, which is my hypotenuse, and it's going to be the inverse. And we're going to put that in the calculator. So I'm going to hit Shift, Sine, fraction button. 15, I could reduce that fraction, but I'm lazy. 25. And boom, 36.9-ish. All right? But that's just this angle, so I'm just going to simply multiply by 2 to get the other angle. So this whole angle right here is about a 73.7. So it's about 73.7 degrees. Okie dokie. And then, of course, we can find the third angle by subtracting from 180. All right. Okie dokie. That is it for this one. Next short lesson coming up.